Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So in this subject, we have learned friction, wear and lubrication topics. But in this session, so I want to discuss about some numerical problems related to this wear and surface treatment. So the wear and surface treatment is very important thing in the engineering tribology to minimize the wear and to improve the performance of the component or product. So in this some numerical problems you have to solve. You have to calculate to measure the wear and heat treatment performance parameters. All these things, how to calculate, we will see. So in this, the numerical problems on wear and surface treatment. So in this, sometimes they will ask problems like this. What he has asked, calculation of wear rate. Wear rate, a steel pin slides against a steel disc. So this is related to under dry conditions. The pin on disc testing against pin and disc testing based on dry conditions or wet conditions. So it will be calculated the wear rate under dry condition one thing and under wet condition secondary. So in this steel disc, against a steel disc, a pin slides slides on this disc. So which material you have to calculate to be calculated wear, that is acted as a pin. So and another one is split disc material is made up of another material. So the applied load is here 200 newtons. The load is 200 newtons and the sliding distance is 500 meters. So the distance you can adjust the distance also. You can see in the pin on disc experiment. The volume of material worn away is measured to be 0.02 centrifugal cm cube and 0.02 cm cube. Repeated this one. Calculate the wear rate in terms of volume loss per unit distance. So what he has asked, calculate the wear rate in terms of volume loss. How do you calculate? The solution is first given load. So you have to write the given load, that is F. How much given? 200 newtons. 200 newtons. And then the sliding distance 500 meters. The volume of material worn away is 0.02 cm cube. Convert into meters, 0.02 10 to the power minus 6 meter cube. The wear rate is given by V upon L. So that is the volume of material upon the sliding distance. So how much wear occurred for a particular distance. So that's wear rate is V by L. So substituting the values now in this substitute, the V is 0.02 into cm cube, that is 10 to the power 6 minus 6 upon L. L is 500 meters. So that is 4 multiplied with 10 to the power minus 11 meter cube per meter. So this is a wear rate calculation for the given load and sliding distance. Clear? So next problem, the determination of specific wear rate. A material undergoes a wear test. So the load of 150 newtons is applied. The sliding speed is 2 meters per second and the test duration is 30 minutes. So the mass loss of the material after the test is 0.05 grams. So the mass loss of the material after the test is 0.05 grams, the density of the material is 7.8 gram per centimeter cube. Calculate the specific wear rate. So what he has asked, specific wear rate, how to calculate. So the specific wear rate for a particular specifications. The load is 150 newtons, sliding speed is 2 meters per second, and the test duration is 30 minutes. The loss of the material is 0.05 grams. So now we will see solution for. So in this, the given load is 150 newtons. The sliding speed 2 meters per second. The test duration, that is T, 30 minutes, convert into seconds. 30 multiplied with 60. So mass loss, that is 0.05 grams, convert into kgs. And density is 7.8 gram per centimeter cube. So then gram per centimeter cube convert into 7.8 10 to the 3 kg per meter cube. The volume loss can be calculated as mass loss upon density. So density is, as per density, definition mass per volume. But here, the volume loss, we are calculating the volume loss, so that the mass loss already given. So upon the volume is mass by rho density. So that substitute those values, you will get the volume loss. Sliding distance, that is, sliding distance is L is equal to volume multiplied with T. Test duration, how much time taken? So 2 meters per second, that is speed, sliding speed, and T is 1800 seconds. The specific wear rate is given by, now calculate the specific wear rate. The specific wear rate is K is equal to V by F into A. It's already shown in this. So, given the volume is, here volume loss 6.41 to 10 to the power minus 9 upon 150. The force is, the load is 150 and L is sliding distance 3600 meters. So that the calculated value is 1.19 multiplied with 10 to the power minus 13 meter cube per Newton meter will get. Next one is calculating wear rate. So a steel pin, already we have seen in the previous problem. So one more problem here in terms of wear rate in terms of volume loss per unit distance. So a steel pin is sliding against a steel plate with an applied normal load of 100 newtons. The sliding distance is 500 meters. The mass loss of the pin is 0.5 grams, 0.5 grams. Calculating the wear rate in terms of volume loss per unit distance. So calculating the wear rate in terms of volume loss for unit distance. So what he has asked here, wear rate he has asked. So now for the given values are normal load of 100 newtons and sliding distance is 500 meters. The solution is first convert the mass loss to volume loss using the density of steel, approx 7.85 gram per centimeter cube. So use the wear rate formula. The wear rate formula is volume loss upon sliding distance multiplied with normal load. So how much loss occurred, volume loss, upon sliding distance, multiply with the normal load. It gives wear rate. The surface hardness increase due to heat treatment. Problem: a steel specimen has a surface hardness of 200 HV before heat treatment. So before heat treatment, how much? The surface hardness 200. After carburizing, so the carburizing is heat treatment process. So many heat treatments are there: normalizing and nitriding, carburizing, annealing. So the surface hardness increase due to heat treatment. So you need to calculate. So how much increased the surface hardness due to this heat treatment process. So after carburizing at 900 degrees centigrade for 8 hours, the surface hardness increased to 600 HV hardness value. Calculate the percentage increase in surface hardness. How much percentage increase? The percentage increase is equal to final hardness minus initial hardness upon initial hardness multiply with 100. So final hardness H minus initial hardness divided by H initial hardness multiply with 100. So it gives 100 and it gives percentage increase. So now here see, substitute the given values. The final hardness is the carburizing 8 hours surface hardness increases to 600 HV. So 600 initial hardness is 200. So upon by 200, so 400 by 200 multiply with 100 in percentage. So 200. First calculate percentage increase. Clear? So you will get enhancement after heat treatment. So corrosion rate calculation. A steel plate exposed to a corrosive environment loses 0.5 mm of its thickness in 2 years. Calculate the corrosion rate in mils per years. The corrosion rate. So how much? MPY. The corrosion rate MPY mils per year, that is thickness loss for time in years. So convert the thickness loss to mils. 1 mil is equal to 0.001 inches. So substitute the values and calculate the corrosion rate. So in this, need to substitute the thickness loss. So how much loss? The corrosion environment losses 0.5 thickness in 2 years. The corrosion rate he has asked. So here the thickness loss 0.5 divided by 2 years. So this is the corrosion rate calculation in MPY. So this one 0.25. So next, mass loss due to corrosion. So a copper pipe with a surface area of 0.5 meter square is exposed to an acidic solution. After 1 year, the pipe loses 10 grams of mass due to corrosion. Calculate the mass loss per unit area, gram per meter square. So here a copper pipe with a surface area of 0.5 meter square is exposed to an acidic solution. So after 1 year, the losses is 10 grams. So here, how do you calculate the mass loss per unit area? Total mass loss. Total mass loss is equal to total mass loss here, because the exposition is after 1 year the pipe loss 10 grams divided by surface area 0.5. So this one will give gram per meter square. So here this value 20 grams per meter square. Galvanic corrosion rate. How do you calculate? An aluminum alloy is galvanizing process already you know. We have studied in corrosion protection coating methods. So an aluminum alloy is coupled with copper in seawater. The potential difference between the metals is 0.7 V. Potential volts in terms of volts. And the resistance of the electrolyte is 0.1 ohm. Calculate the current flowing between the two metals and estimate the corrosion rate of the aluminum if its area is 0.02 meter square. So here given the potential difference is 0.7 and the resistance of the electrolyte 0.1. She has asked current, how much current between the two metals. So the calculate the current using Ohm's law, that is I is equal to V by R. So already you know. So use Faraday's law to calculate the mass loss of aluminum, considering the current and the electrochemical equivalent. So fitting corrosion depth. A stainless steel tank is subjected to fitting corrosion, resulting in pits with a maximum depth of 0.3 mm over 5 years. Calculate the average corrosion rate in mm per year. So the corrosion rate is fit depth for time. So here, what is the fit depth here given 0.3. What is the time? 5 years. Very simple calculation. Calculate the average corrosion rate in mm per year. So the fit depth given 0.3 and number of years is here 5. So you will get 0.06 the corrosion rate mm per year. 0.06 mm per year. That is the corrosion rate. Next, electrochemical corrosion calculation. So metal structure is in seawater experiences uniform corrosion with a current density of 5 into 10 to the power minus 7 ampere per centimeter square. If the equivalent weight of the metal is 27.93 gram. Calculate the corrosion rate in millimeters per year. So use the following formula for a corrosion rate. The corrosion rate mm per year is equal to K into I into EW by rho. So here where K is constant, that is 3.27 times, and the I is the current density, EW is the equivalent weight, and rho is the density. So substitute the values and calculate the corrosion rate. So the whatever values given, these values substitute in the above formula and calculate the corrosion rate. What is that formula? Ki is equal to the corrosion rate is equal to KIEW by rho. You will get corrosion rate. Next, contact pressure calculation. So whenever two cylindrical rollers with diameters 50 mm each are in contact, the applied normal force is 2000. Calculate the contact pressure. If the contact area is approximated as a circle with a diameter of 5 mm, So here contact pressure normal force per contact area. Convert the diameter to the contact area to radius and calculate the area and substitute the values. The contact pressure is a normal force upon contact area. Wear rate calculation. So how do you calculate wear rate? Already we have discussed in pin on disc test. A sliding test is conducted where a steel pin wears out by 0.2 mm over 1000 meter. Calculate the wear rate in meter cube per meter. So here volume loss upon sliding distance. So this is the formula. So apply this formula and calculate the volume loss. Here assume cylindrical pin and use of the pin diameter and wear depth. So these are the references I have taken for this problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.